So before moving to South America in specific climate context, we will read some more text from the book about the interpretations that various authors offer. This is from a longish read from Brooks, and he has some specific views on how to interpret climate perturbation, societal response, societal resilience, and how changes happen, whether climate is directly responsible or societal restructuring preceding climate perturbations actually end up determining the responses and so on. It is now well established that the earliest complex, highly organized state-level societies emerged at a time of increasing aridity throughout the global monsoon belt. So now it's the global monsoon concept that we've been looking at. This trend towards desiccation commenced around 8 kiloyear before present, as a result of declining solar insolation associated with changes in the Earth's orbital parameters, but accelerated around 6 kiloyear BP after widespread centennial-scale arid episode that may have been the result of transient cooling in the North Atlantic. So it could be a perturbation to the AMOC, the Atlantic Meridional Overturning Circulation, or it could be just pure internal variability. The AMOC perturbation could have been a result of the orbital forcing that is mentioned here. The following millennium was a time of profound cultural changes that saw the development of the world's first states in Mesopotamia and Egypt, and laid the foundations for similar developments in South Asia, northern China, and northern South America. The available data suggests further abrupt changes in climate in the 6th millennium BP, when regional records indicate environmental and cultural discontinuities. Remember, now we are getting towards the glacial melt and the flooding, Noah's flood, and so on around this period as well, dated to 9,600 years before present. The available data suggests further abrupt change in the late 6th millennium BP, as we said, when regional records indicate environmental and cultural discontinuity. So there is a relation there. The period around 5.2 kiloyear BP seems particularly significant. At this time, a unified Egyptian state emerged, and Uruk culture of Mesopotamia collapsed and gave way to the transitional Jemedet Nasr period, characterized by fragmentation and regionalism. So collapse is word used again here. In South Asia, the beginnings of the early Harappan phase have been placed at 5.2 kiloyear BP, and the beginnings of urbanization are evident at the site of Harappa. So it's in northern China, there is evidence for an abrupt drop in temperature and accelerated aridity, coinciding with the Yangshao and Longshan transition in the final centuries of the late 6th millennium BP. In South America, this period was characterized by profound changes in the ENSO cycle and an increase in coastal upwelling. So we are invoking variance change in ENSO that we looked at here. And that was prior to the emergence of large urban centers exhibiting monumental architecture. So upwelling always leads to enhanced upwelling, always comes with higher primary productivity, fish, marine food sources. Changes in the behavior of the monsoon systems appear to be one aspect of a wider reorganization of the global climate. Okay, and there is abundant evidence of regional environmental desiccation, and while the trajectories of social change in Mesopotamia and Egypt are very different, in both cases increasing social complexity is associated with increases in local population densities and the congregation of populations along rivers, and evidence of competition or conflict at the end of the 6th millennium BP. In Egypt, this occurs within a context of political unification, whereas in Mesopotamia, the context is one of fragmentation. In both cases, environmental deterioration coincides with trends towards greater urbanization and the development of ideologies of political power. So I'm just trying to make the point that the same climate evidence and archaeological and other evidences are combined to provide these narratives by different authors. And this one again goes back to the Harappan. According to Posel, the Harappan civilization created a distinctive set of signs and symbols that can easily be differentiated both from what came before it and from the material culture of the contemporary peoples in adjacent regions. This is from Brooks as well. Posel infers that the changes had an ideological component and that trading with Mesopotamia may have had significant sociological impact. Okay, so there was already this communication between two very different cultures, but they obviously would have influenced each other according to this interpretation. Brooks again remarks, whether organized trade, formal religious ideology, and social stratification and differentiations are the driving factors behind the emergence of complex civilization, or more likely products of it. So whether trade and religious ideologies and social stratification and differentiation were the driving factors between the emergence of complex civilizations, or whether they were products of it, is a matter of some debate. Okay, once the transition to such a society is underway, we can be confident that these factors will interact, and it is the nature of this interaction, mediated by the broader environmental context, that gives a complex society its unique identity. Right? Whether a culture becomes agriculturally rich in a wet monsoon region, or it becomes good at trading and exploitation of marine resources and so on in another drier context like Mesopotamia, and then how societies respond locally and how they are affected by interactions with other cultures they are trading with, is obviously always complex in the environmental, with the background environmental drivers affecting both in different ways and responses being different as well. Brooks favors increasing aridity as the most significant cause. It forced pastoral groups to settle along the rivers where populations grew larger, with resulting social change that he compares with the developments along the Nile. Okay, so you can see how various regions, various climates are combined with various cultural evidences to interpret things. Looking here at South America, this is the ITCZ with the warm Gulf of Mexico that is argued to pull the ITCZ way north in September, boreal summer, whereas in winter there is more complicated. Of course, ITCZ tries to go south with the sun, but there are reasons why this remains north, and there are debates about whether that is related to land mass being larger in the north, or in fact it is the northward energy transport by the Atlantic meridional circulation that requires atmospheric southward transport, which is accomplished by an ITCZ that stays north, and that's called the energy equator. But those are details I have talked about elsewhere in other podcasts. The Amazonian region, you can see the ITCZ dips way south, giving it the rich vegetation. So these are the seasonal variations in the mean position of the ITCZ over Mesoamerica and northern South America, illustrated for typical summer and winter conditions. These variations control the pattern and timing of regional rainfall. Obviously, numbers and colors reflect sea surface temperatures in degrees Celsius. Locations of the Cariaco Basin study area and Maya lowlands are indicated. Both regions are similarly affected by seasonal and longer-term changes in the position of the ITCZ. So here is the Maya lowlands, and here the Cariaco Basin. This, of course, has been a story that always comes up in the Holocene climate impact studies. So looking here at the period going, or this is the depth of the course, and this is converted to time periods, so you can see how translation happens between the two. So the location of the ITCZ being north or south, and precipitation and river runoff, Cariaco evidence comes from runoff corresponding to rainfall. So bulk of the titanium content 3-point running mean here, etc. In the Cariaco Basin during the past 2000 years, the timing of well-known climate events such as the Little Ice Age and major events in the history of Maya civilizations are shown here. So this is the medieval warm period and this is the Little Ice Age, and here is 8200s pre-classic abandonment, and this is 8800s terminal classic collapse. So again, sticking with the word collapse there, the relation with the migration of the ITCZ and lower river runoffs is seen as an impact on Maya lowlands. Okay, the pre-classic abandonment and the terminal classic collapse of Maya culture coincided with the phases of low riverine derived titanium input to the Cariaco Basin and with inferred dry conditions in the region. Here, the bulk TI content, 30-point running mean, etc., of a 30 centimeter long slab sample from companion ocean drilling program hole with this number in the time interval between 1.8 to 1.0 thousand years ago confirms these trends and shows increased detail. Periods of drought marked by low TI values in the sediments are likely the result of climatic conditions that prevented the ITCZ and its associated rainfall from penetrating as far north as normal. So you can see that the normal position is just over the Maya lowlands. So during the wet period, you can imagine how the civilization got established, and they didn't count on the longer term changes. There is a seasonal change from summer to winter, which they can of course deal with, but when the ITCZ shifts and produces low frequency changes, centennial, multi-decadal changes in rainfall and runoff as recorded here, indicating ITCZ position, then it would lead to serious perturbations to the civilization. Okay. I will come back and look at Fagan's book a little bit later on, but coming closer to the end of the chapter, I'll just read these off. To summarize Fagan's general conclusions, he distinguishes three major effects of climate change on culture. People move to more suitable environments, a process possible when populations are low. If you have a large, established, dense urban environment, then moving lock, stock and barrel is not going to be easy. Some migration provided cheap labor, improved social organization and central control of irrigation and agriculture. So this is coming back to climate and agriculture, which is the nominal title of this chapter, even though we have wandered in many directions. Collapse of civilization occurred because of starvation, rejection of rulers' claims to be able to call on the gods for improvement, and the lack of anywhere else to go, therefore war. So this is a more complicated combination of factors where some societies had rulers who were innovating in terms of irrigation, land taxes, trading, etc., to increase resilience, and they were better prepared to deal with at least minor perturbations in climate with hydrological structures and irrigation and so on. But some were relying on gods for improvement of bad climate, which then obviously led to other problems, and militarization would have happened along the way in many cultures and would have led to wars. Okay, so we'll come back and conclude this longish chapter, which is quite interesting anyways, in terms of human interactions with climate and how evolution of agriculture happened along the way. Even though at every step we didn't make the link to agriculture, you can imagine that aridification, wet periods, dry periods, warm periods, cold periods, vegetation changes, and all are directly or indirectly related to agriculture, even though we didn't say as much. But we will look at a long table before concluding that provides context for some more links that we didn't explicitly say so far. Okay.